So, as some of you might know, I go to Oxford University, which is quite exciting. But it also means that I have interaction with people from other subjects. Some of you might know I do physics. But James here, James.
Hi.
This is James.
Hi.
Oh, let me get him in. He does chemistry, and I asked him whether he wants to be in the video, and he said yes. Yeah?
Yeah.
And he said he's going to tell us some interesting chemistry stuff.
Well, it depends what you ask.
Right, okay.
If you ask the right questions, I can tell.
Right, well you had something interesting you were telling me about, like folding wine rack crystals or something.
Yeah. Well, this isn't something I'm actually going to be doing, which is a shame, but next year I get to do some quite cool research.
Yeah.
So I got to choose who I applied for, and I ended up going with organic chemistry, which is...
Organic,
you know,
so that's chemistry that involves carbon.
basically chemistry that involves carbon.
Right.
Well, yeah, exactly, chemistry that involves carbon.
Chemistry involves carbon, organic chemistry.
Yeah, but the stuff that is quite cool, that I kind of regret not going for, but it's not as employable for a start, I don't think. And yeah, it's not the sort of thing that you can really put on your CV as much, but it passes the bar test, you know. You go into a bar, somebody says, what do? You go, well, I do this really cool stuff with. But I'll tell you what it is. It's basically the things that he does. He has these crazy cool crystals.
Who?
Oh, Dr. Goodwin, his name.
Dr. Goodwin, does he work for Oxford?
Yeah, he does. He's in the
Do you know?
NCL. He does a couple of my lectures. I've talked to him.
So
I'm sure he doesn't know me.
He does your lectures for organic.
For inorganic.
Inorganic. So he does. Okay, right. So tell me about Dr. Goodwin and his experiment.
Well, he has these crazy cool collapsible crystals, and they're really nifty. If you imagine a collapsible wine rack, right? But if you imagine it in 3 dimensions.
So this is the cross section, like X-shaped wine rack.
X-shaped wine rack
that you would fold out.
It in like a tripod like that.
Yeah.
But he has these crystals. Crystals are generally sort of like an octahedral array of atoms, related to each other with six different atoms on each different axis of another atom.
So, go again. So they're like... So there's 3 axes.
Normally you'd have 3 axes like this.
Right. So yeah, planes like a cubic.
Like
if you imagine like atoms in a cube.
Yeah, atoms in a cube.
So what does he have?
Well, he has atoms that have the same sort of thing, but between each atom they have a linear bit, and that attaches at one end, and that's like a hinge. And so they can... It's weird, you're making a weird face.
No,
it's weird.
Yeah, no, I'm making a weird face, but I like to explain. Because I think we can understand.
Because there's you have these sort of linear mercury compounds between each bit, and they act as a hinge, and they sort of go like this. And so, as a result, the entire crystal can collapse.
So there's these mercury compounds that allow the cubic structure to collapse.
To collapse on itself, yeah. So you can have like a whole sort of solid, and you put it on a higher pressure, and it will have, under higher pressure, it will have a lower volume form that it can take, where the entire thing just goes...
So it's a squishable...
It's a squishable crystal.
A squishable crystal.
Which is really, really weird.
So what would you...
Really quite cool. It has absolutely no point to it.
I think it probably does.
It hasn't yet.
Can you imagine he is?
Well, they're doing their best.
Nano wine rack.
They managed to intercalate, which means put in like lithium into it, but they can't put it in and take it out. But they can do it with putting. Yeah, they can put it in as they make it. But if you can put it in and take it out, sort of like once it's already been made, then it can act as a battery.
Battery. So there's some battery.
Yeah, it's anisotropic as well. So
this means it's not the same in every direction.
Not the same in every direction.
Well, like a wine rack isn't the same in every direction. You can't fold a wine rack in like a certain way.
So actually there are directions in which if you could put ions in, ions would prefer to flow. So you can make it as a battery that will conduct in one direction but not the other. Okay. Which is quite nifty. What else does it do? It has a negative Poisson number. Now this is cool.
Well, no, okay.
Poisson number
is.
You imagine
what's
a ball of goo.
Number?
You poke a ball of goo. You expect a ball of goo to expand in all the directions that you don't poke it in. If you poke it.
If you poke.
Oh, it's common sense.
So if you have a ball of goo and you poke it, you'd expect it to get bigger in every direction, apart from in your finger.
Yes.
Yeah.
Exactly. I mean, it's common sense. It's obvious.
Yeah.
And that's a positive Poisson number. This one is weird. It's anisotropic. So if you poke it in one direction, it will shrink. In a certain other direction. If you poke it on the x-axis, it will shrink on the y-axis.
So if you poke it like north, it will shrink in east.
But it will expand in upwards and downwards.
Right. That's cool.
It's weird, isn't it?
That is weird.
It's really
Does that happen on like a visible scale?
It happens on quite a small scale.
Okay.
But it still is like a really really nifty thing. I was gonna apply for my part 2. My part 2 is the 4th year of my degree.
Right.
Because the first 3 years are fairly theory based.
Yeah.
The 4th year is
It's an actual, like, you do a project.
It's research. I mean,
yeah.
we wouldn't really be employable at all at Oxford if we didn't do a 4th year, because we do so little research in our first 3 years. Well, we do no research at all. We do occasional labs, but we do actually very little practical work, and we wouldn't be employed if we didn't do a 4th year. So.
Okay. Cool.
Yeah.
So yeah, thank you for talking to us, James.
You're very welcome.
I don't know if
I
I'll
hope
ever.
I've been interesting.
I don't know if I'll. You are interesting. I don't know anything about chemistry, so that was interesting. And hopefully I've managed to come across well all the things we talked about. I don't know if I'll ever do this again, but it was pretty interesting this time, so maybe I will. This has been me and James.
You're welcome, and apologies for any drunkenness.
Apologies for any drunkenness. We've just come back from the pub, and I hadn't filmed a video, so I thought, James, do you want to do a video? Yeah, we want to do a video. Thank you very much, and I'll see you tomorrow.